So our notes, finding the inverse of a 2 by 2 matrix, okay? So recall that what we just did do now is that you were determining if two matrices are inverses. And for that, you will multiply A times B, you will multiply B times A, and both products have to equal the identity matrix, right? And the identity matrix of a 2 by 2 is 1, 0, 0, 1. Remember this? That's what we have to do now to recall this information. You don't have to write this down because you have notes over it already, but it's just recall this information. Yes, we just applied it, just used it, cool. Now, steps to finding the inverse matrix. So when you're looking for the inverse matrix, this is what we do. Step one is you find the determinant of the matrix. So that's the very first thing you do is find the determinant. I spelled determinant wrong. I wrote determinate. Just realized that. Oh well. I'm a math teacher for a reason. Determinant of a matrix. So the determinant of A, if it equals 0, then there is no inverse, okay? There is not an inverse. If the determinant does not equal 0, then there is an inverse. Pretty straightforward. Equals 0, not an inverse. Doesn't equal 0, there's an inverse. Got it? Next, you're going to identify the elements A, B, C, and D of the matrix, okay? And then with the elements, you're going to plug them into the formula. So your inverse formula is A to the negative 1 equals 1 divided by the determinant times this new matrix. And basically what's happening with the original matrix is that your main diagonal elements, they're going to switch places. And your minor diagonal elements, they change signs. So main switch places, minor change signs. The reason why this is called your main diagonal is because we read from left to right. So from left to right, this is my first diagonal. Does that make sense? So my main diagonal, they switch places. My minor diagonal, they change signs. And that's how the formula is made up. Once everything is where it needs to be, you're going to evaluate the formula, and then that's your inverse. Does it sound doable? I hope so. Are you ready, Freddies, to apply, to try? So here's our first problem. We have A equals -3, 6, -1, 3. And it wants to know, does it have an inverse? And if it does, what is the inverse? Okay, so step one is to find the determinant. So the first thing we're going to do is find the determinant of A. And that comes from -3 times 3 minus -1 times, well, 6 times -1. A negative times a negative is a positive. So I have -9 plus 6, and that equals -3. Not equal to 0, so there is a determinant. So there is an inverse. Inverse exists. Questions about step one? Cool? All right. Step two told us to identify the elements. So you're just basically looking, making sure. So you know what your elements are. A, B, C, D. Everyone knows, everyone got it. Elements identified. If you want to write them out, you can. You can write A equals -3, B equals 6, C equals -1, and D equals 3. 3 is plugging everything into the formula. So the inverse equals 1 over the determinant times D, -B, -C, A. So we plug everything in, and our determinant was -3. So we have 1 over -3. Our D is 3. Our negative B is -6. Our C would become a +1. And our A is -3. 4 is you evaluate. So I'm going to apply the scalar to each element. So that gives me 3 times negative 1/3, negative 6 times negative 1/3, 1 times negative 1/3, and negative 3 times negative 1/3. Well, 3 times negative 1/3 is negative 1. Negative 6 times negative 1/3 is positive 2. 1 times negative 1/3 is negative 1/3. Negative 3 times negative 1/3 is positive 1. So that would be your inverse. All right, questions about the steps? Doable, not doable, okay? Doable. See, we've just now taken all the skills we've slowly learned, right? And merged those bad boys together. All right. So here we go. I would like for you to try. Talk to each other, help each other. People at home, please feel free to communicate with us as well. But here's one for you all to try, and then we'll go from there. Okay, so step 1 told you to find the determinant of A, which equals 4 times 2 minus 2 times 3, which equals 8 minus 6, which equals 2. Does not equal to 0, so there is an inverse, right? All right, step 2 is to identify your elements. A equals 4, B equals 2, C equals 3, and D equals 2. Then step 3, you're using the formula. Inverse formula equals 1 over the determinant of A times D, negative B, negative C, A. So you have 1 over 2 times 2, negative 2, negative 3, and 4. 4 is you evaluate that, and you end up with 2 times 1/2, negative 2 times 1/2, negative 3 times 1/2, and 4 times 1/2. And you get 1, negative 1, negative 3/2, and 2. How did we do? Cool? Easy enough? Are we good at home? I hope so. All right. Just one more to verify that we're good to go. So step 1, find the determinant of A. So we have 5 times 3 minus 2 times 7. That gives us 15 minus 14, which equals 1. Not equal to 0, so there is an inverse. Step 2, our elements are A equals 5, B equals 2, C equals 7, and D equals 3. Plugging into formula, 1 over the determinant of A times D, negative B, negative C, and A. So that gives me 1 over 1 times, and this one's pretty easy, 3, negative 2, negative 7, and 5. 1 times anything is its, so step 4 is done. All right, yay, we can find the inverse, okay? This skill is gonna be extremely useful for Monday when we are solving inverse related problems, okay? What the plan is for tomorrow. Tomorrow we will have a 4-3 quiz. So we've been learning 4-3 all week long. Tomorrow we will have a quiz over 4-3. It is open notes. So if you've been taking your notes like you should, then awesome sauce. If you haven't, then, you know. And then the rest of the day is a work day. So getting assignments done, makeup work, completing this assignment. If you don't complete it today in class, you'll have tomorrow in class to work on it as well. But yeah, so the plan tomorrow, it's a work day. We have a quiz, and then the rest of the period is for you to work on your work for the week, work on any of the makeup or retake assignments that are made available. Any questions, comments, or concerns? Awesome sauce.